Welcome to SanfordFlipMath. This is Algebra 2. We are working through solving systems of equations. We just began when we last met. We were working with solving systems by graphing, and I just want to remind you that the goal of, well, first of all, a system of equations, remember, is just more than one equation. Usually involves more than one variable. And remember that the goal is to, when we're solving a system, is to find the values that make all of the equations true. Okay, so I just wanted to remind you that that's the goal, is to find the values that make all of the equations true. Here's an example of a system. We want to find all of the values, or we want to find the values that make all of these equations true. And in order to make these equations true, we need to have both an x value and a y value. Because we have x and y, we won't know if it's true unless we can fill in both of them. This video is going to focus specifically on solving systems by substitution. There are many ways to solve systems. You can use a table of values and look for y values that match. You can use a graph and find out where the lines intersect. Then there's substitution, elimination, matrices, etc. This is focused on substitution. As you're probably aware, substitution basically just means replacing. And what we're going to do is try and take these two equations with two variables and make a replacement so that we can end up with one equation with one variable. That's the goal. If we can get one equation with one variable, then we can solve for that one variable. That's what we would like to do. That's stuff we already know how to do. Okay? So what I'm going to recommend is you look for an equation that has a variable by itself. So the idea is, with this equation that has a variable already by itself, I know that y is the same thing as x minus 2. So what I'm going to do is rewrite that other equation, and I'm just going to say, well, 2x plus 4y equals 4. Now, I specifically wrote it with a lot of space here because I'm really not going to write the letter y here, the variable y here. I'm going to write something that's the same as y. So really what I'm going to do is take something that's the same as y and make a replacement. Originally this 4 was multiplying all of y. So what I want to do now is multiply all of y, which is really x minus 2. Okay, so let me write that one more time just so it's it'll stand out by itself. Okay, so I'm going to read through this again. The original equation was 2x plus 4y equals 4. Well, this is y. Okay, so again, the goal was just to make a replacement. So what that replacement lets us do now is, notice I have one equation with one variable now. So I need to solve it. Okay, so this is now becoming an easier problem. I need to distribute, so 4x minus 8 equals 4, combining like terms. Add 8 to both sides. Oh, and while we're zooming along here, let me throw out a little thank you to PatrickJMT because I stole the problems off of his video. I just wanted to have my own dialogue going. So appreciate the systems of equations. Okay, so x equals 2 is what we got. Quick question, are we done? Felt like Dora right there. Not really, because we need an x and a y value. Okay, so I have an x value, again, x equals 2. Now, the problem is I need to know the y value that goes with that. Okay, well, I can get y from here. So how about I put in, again, substitute, y equals 2 minus 2, so y equals 0. So the ordered pair that makes this true, the solution for the system should be 2, 0. Well, what I'd like to do is kind of double check that. Okay, so 2x plus 4y equals 4. And again, the other equation was y equals x minus 2. Sorry about all the sliding. Okay, I just want to double check that this works. Okay, now I'm just confirming. Okay, so putting 2 in for x, putting 0 in for y. 2 times 2 plus 4 times 0 equals 4. This is 4 plus 0 equals 4. Lo and behold, that is true. Okay, so that did work there. And then the other one, so y is 0. 2 minus 2. Again, what I'm doing is substituting x and y, and 0 does equal 0, so that worked too. So I'm just confirming that that worked. Generally, I don't require students to write down all of that. I just wanted to show you that yes, in fact, that does work. Remember to check it. It needs to work in all equations, not just one, but in all of them. Okay, so that's example 1. This one was really set up for substitution right out of the gate. So what I'd like to do is do at least one more and maybe a couple more that are not so cute. Okay. So again, we're solving by substitution, and the idea is I'm going to replace a variable with something it's equal with. Well, I don't have an x equals. I don't have a y equals at this point. So I need to force that to happen. So what I'd like to do is solve for one of them, and I want to solve for whatever variable is easiest to solve for. Which one is the one that's easiest to get by itself? Well, I'm here to tell you that this x is almost by itself right now. So what I'd like to do is take that equation and solve for x. So I'm going to subtract 3y. I'm not trying to make slope-intercept form. I mean, that would be acceptable. Anytime you have a variable by itself, you're good to go. Okay, now again, if you want to write this 6 minus 3y, you're welcome to do that. Okay, so I'm going to take this equation, and I'm going to use it to replace x in the other equation. Now, if I don't want to put it back in this first equation, because the first equation and this equation I just made are really equivalent. They're virtually the same equation, so that's not going to be helpful. So instead, what I'll do is put it in to this equation. Okay, so that equation says 2x plus 6y equals negative 12. Now again, I'm leaving a lot of space because I want you to see what I'm going to do is, right where that x is, I'm going to replace it with something that's the same as x. This is the same as x. So this becomes negative 6y plus 12 plus 6y equals negative 12. So, well, isn't this interesting? Okay, let me stop. Let me just kind of pause myself, and I'll be... Okay, so you didn't catch that pause, but I paused myself. So I just think this is really interesting. Obviously, I did not watch PatrickJMT's video beforehand. So what I have here is, notice negative 6y plus 6y. Those happen to go away. And what I'm left with is 12 equals negative 12. Isn't that interesting? Well, here's the situation. What has happened is we have no solution. Okay, so anytime the variable disappears, if the variable disappears, then either something's true or something's false. So the variable's completely gone, and what I'm left with is 12 equals negative 12. Well, you're probably aware of the fact that 12 does not equal negative 12. This is a false statement. If there's no variable and it's false, there's no solution. So what just happened was, these two lines, the original equations we have, were actually, if we graph them, they would be parallel. Okay, so what we have is a situation where if I graph this first line, it's going to have a slope or a y-intercept of 2 and a slope of negative 1/3. It would look something like this. And the other equation, if we graph it, it has a slope, a y-intercept of negative 2 and a slope of negative 1/3. They would never intersect. Okay, so this particular system, no solution. Okay. Another word that goes with this is inconsistent. Since there's no solution, this system is inconsistent. Okay. All right, let me pop back real quick. because this system had a single solution, this is consistent and independent. Many solutions is dependent. Okay. All right, just a reminder that you can pause, you can rewind, you can do whatever you need to do. You are in control while you're watching this video. Okay. I'd like to do one more example. I don't believe it'll come out funky like that one did, but it will come out, it's going to be a little uglier. Okay. All right, hang on. All right, quick change. Okay, so I don't know if you saw the system here pop up, but then I saw something that I didn't like about it, so I'm switching it. Okay, so what we're going to do is solve one more system, and then we'll be done. And the reason I picked this one is it's not so cute. Okay, so I'm purposely picking one that's ugly so we can see how this plays out, and I know this is going to involve your not so favorite thing, fractions. Okay. If you make good choices about what variable you're going to pick to solve for, remember you have to solve for one variable. And you're going to get it by itself. And the idea is you want to pick the easiest one. Well, you may notice things that some other people don't. So it shouldn't really matter. I'm going to purposely pick one that's not so easy to work with just because well, actually, I'm going to not pick x. I'll pick y because I picked x before. Okay, so I'm going to pick this y, and I'm going to solve for that. So I'm going to take 3x minus 5y equals 10, and I'm going to get y by itself. So I'm going to subtract 3x from both sides. This is going to end up being slope-intercept form. It doesn't have to be slope-intercept form. That's just, since I'm solving for y, that's just what it's going to end up being. Okay, so I have y equals 3/5 minus 2. Okay, so what I'm going to do then is take this equation and I'm going to replace the y in the other equation with it. Okay, so it's going to go into there. Okay, so here's the original first equation. Okay, and again, what I'm doing is I'm replacing the y with what y is equal to. So this guy right here is going to go up there. So 3/5 x minus 2. I'm replacing y with what y is equal to. Okay. Well, this isn't going to be very cute. Just kind of roll with it. 2x minus, well, 4 times 3/5. Remember, 4 is 4 over 1. So this is going to be 12/5 x. And then a negative 4 times a negative 2. This ends up being plus 8 equals 4. Okay. Well, I'd like to combine some like terms. I know some of you are going to want to make that into a decimal. I guess you can. I'm going to work with it like it is. So a quick little side note here, 2x minus 12/5 x. Well, 12/5 that's fifths. In order to subtract fractions, I need to have a common denominator. Well, this is currently over 1. So I'm going to multiply the top and bottom by 5. So this ends up being 10/5 minus 12/5, also known as, Mr. Sanford, that was a lot of work. Yep. Well, there is an expectation that you're going to remember how to do stuff, and if not, we'll have to fill in the blanks as we go along. Okay, so this is negative 2/5 x plus 8 equals 4. We're almost done with this part. Now remember, I purposely did this. You know, I wanted to find one that was ugly because sometimes ugly happens. Okay? And then we're not such a big fan of fractions here, and we need to get x by itself. So I'm going to divide both sides by negative 2/5. Now I'm saying the words divide by negative 2/5, but notice what I'm writing. Because division by a fraction is the same thing as multiplying by the reciprocal. So the 5's divide out, the negative 2's divide out, I'm left with just x. On the right side, I actually have the negative 4 and the negative 2 are going to reduce. This is actually 10. Well, that came out kind of nice, didn't it? Okay, so where we're going from here is we have to still solve for y. I'm going to go to the equation that says y equals. Yes, that fraction again. All right, so and then we're almost done, so don't freak out at me. So 3/5 times 10 minus 2. Now again, a reminder that 10 is the same thing as 10 over 1. So this really is y equals, well, the 5's divide out, leaving 3 times 2 is 6, minus 2 is 4. And you'll be happy to know that we're done. We just need to write this as an ordered pair. So the solution to this system is 10, 4. I'm going to leave it to you to go back and check it to make sure it really worked. Okay, I did it on another sheet of paper, so I'm pretty confident about it. Okay, so just a reminder that substitution is about substituting, making a replacement. The goal of that replacement is to replace a variable so that we end up with a single equation with a single variable that we can then solve. Okay, so that's what happened when we got here. We had a single equation with a single variable. Okay, all right, well, that's it. This is substitution. This is one method of like 4 or 5 that we're talking about right now. And again, the reason is that sometimes certain methods just seem to apply based on the setup of the system. Okay. All right. Well, thanks for watching. This has been Sanford Flip Math, and we're out. Bye.